Perfect. So that was just a highlight reel of made with Unity games. Oh, sorry. It's always exciting to see people working on games, working on any type of real-time applications using Unity. I'm very excited to be here today, to be honest. Thanks everybody who made this possible. My name is Arturo. I'm a developer advocate at Unity, and sorry, we recently changed our titles, so that's why I was not sure what was my title, but yeah, that's my Twitter there. If you ever need anything from Unity, or if I can be of any help, always feel free to reach out to me. I'm always happy to help. And today we're gonna cover one of those topics that I'm really passionate about, which is it's graphics, computer graphics in Unity. And in particular, we're going to talk about the universal render pipeline. We're gonna learn throughout the session what is a render pipeline, what is a scriptable render pipeline, what is the universal render pipeline. We're going to take a look at some demos that you will be able to also play around with at your own leisure. So when you have time and you want to do what I did here, you will be able to do so. I would like to ask some questions before we start, and I think we have the interaction active, right, Elena? Like people can.
I believe so. We can go ahead and answer questions in chat, and there is a Q&A feature as well available.
Okay, perfect. Yeah, well, if you have any question, feel free to ask on the chat, or yeah, okay. Michael raised his hand. So I would like to ask you, and if you can, to tell me who here is working on games, like games, video games, creating video games. Okay, Harsh, Billy, Kahendra. I'm sorry if I mispronounce some names. Michael, Isaac. Perfect. So I will assume that most of us here know what Unity is. We have made some demos with Unity, or we have released games. The topic itself is not necessarily like something out of this world regarding complexity. However, is something newish to Unity developers, because in the past we were not, Unity didn't offer that much flexibility on how to modify the rendering of our games or applications. So this is kind of new to Unity developers. However, it's super exciting. If you are starting with Unity, also don't think that everything is so complex as it is on this topic. This is I would say this is an advanced topic. So just knowing how these things work is great for you, just to have this knowledge under your belt, basically. So I'm gonna start, and first, I think I need to change my screen resolution because I had it like super high, and I'm not sure if I changed it before. Okay, yeah. So let's go back to the presentation, and feel free to ask any question. Also, I was going to mention that thanks for joining. I know it's kind of late for you. It's not that late for me. I also want to add that I'm based in Austin, Texas, in the United States, but I'm originally from Mexico City. So okay, so this is the agenda for today. It looks like it has a lot of items there. It does, but I just hope that you have fun, that you've learned something new. Don't worry about memorizing any of these particular topics, and I'm gonna tell you why. One is because these things are changing so fast that one option that today is in one place, tomorrow is probably gonna be in another place. So don't worry about memorizing the where the buttons are, etc. Just try to understand what can be achieved, how can be achieved. And then once you have to implement something, you'll be able to remember like, oh, I remember this presentation and I remember I could do this or I could do that. And then you will go to the Unity website, the documentation page or tutorials, etc. So we're going to talk about the SRPs, which are scriptable render pipelines. And we're going to cover the universal render pipeline. We're going to talk about the foundation of the SRPs and the foundation of the universal render pipeline. We're going to talk about some recent features and some upcoming or new features, and then what's the future of the universal render pipeline. So let's start by talking about scriptable render pipelines. And before the scriptable render pipelines, let's talk about render pipelines in general. So you know, when you're working on a game, when you have your Unity editor open, you have the scene view, and everything there is 3D, right? We have, even if we're working on a 2D in a 2D game, actually it's just a plane or a quad that renders a sprite, but everything in Unity is in reality 3D. Now, how can Unity convert a 3D scene into a 2D image? And I'm saying 2D image because at the end of the day, all of our games, even if they are made with 3D meshes, etc., we are rendering them into a monitor, a 2D monitor. Even if we're rendering them to, let's say, a mobile device, a console, and it renders into a TV. Even if it's like a headset, a VR headset, we are rendering to 2D monitors in reality. So we have to convert the 3D information into 2D images. That's what it's called a render pipeline, right? And it is a pipeline. It goes from 3D to a 2D image. Multiple things happen in between. We will cover some of them, but yeah, that's a render pipeline. Now, scriptable render pipeline. And before having these scriptable render pipelines, we have in Unity something called a fixed render pipeline. That means that all the games in Unity will be rendered the same way. Basically, you as a developer in the past didn't have the flexibility or control over how Unity will render your game. So imagine you're making a game such as Cuphead or making a game such as Pokemon Go. Internally, Unity will be rendered those games the same way, which doesn't really make a lot of sense because they are different games. They have different needs and they look way, way different. So in starting Unity 2018, we started moving away from a fixed render pipeline and we started working on a scriptable render pipeline approach. What does this mean? That instead of just telling Unity, okay, render my scene, we now can tell Unity how to render the scene. So you can tell Unity, okay, I want you to follow this order. I want you to render these objects after this stage in the render pipeline, etc. You have more control over how Unity renders your games. And you actually could tell Unity that you need some specifics for your game, some features for your game, and you could implement those specifics for your game. If you're going after, if you're targeting like hardware that is not like super common or graphics libraries that are probably not super common or something, you could potentially be able to render those into those platforms. So scriptable render pipeline, and again, I cannot see the chat at all times because of my notes here. But yeah, if you have questions, please feel free to ask them. So what is the scriptable render pipeline? And we haven't talked about the universal render pipeline. We're still talking about the scriptable render pipelines. It's a C# rendering API layer. That means all the code is in C#. You don't have to code anything on C++. Most of the functions and most of the abstraction lives in the C# world. So you don't have to worry about anything else like learning anything new, etc. It's C#. It comes with some rendering solutions, but also you can create your own rendering solutions, and we will talk about that in a second. It's open source. The C# code is available on GitHub. So unlike in the past where the rendering pipeline was a black box, where you had no idea how anything was working on the rendering side. Now you can go, you can grab the code, and you can inspect and get like an overview of how things are actually working. Unity provides two render pipelines. One is the universal render pipeline, and the other one is the high definition render pipeline. These two options are basically two render pipelines that you can use, that you literally just need to download from the package manager, install them in your project, configure them in your project, and you don't have to do anything else if you don't need to. It's great. These are great. They work. We are gonna be adding support to like new hardware, to new graphic libraries, etc. But there's also a third option, which is the custom render pipeline. This means you could create your own render pipeline if you want. To be honest, I wouldn't recommend you to go that path unless you are like a graphics programmer and you really need something very specific for your game or for your application. And I'm saying this because it takes a lot of work to create your own custom render pipeline. However, that's a possibility, and it's great. If you end up using universal render pipeline or high definition render pipeline, you can still extend those render pipelines, and we're going to talk about how to extend those render pipelines. If you right now are working on a game and you don't need any of these features, or you have been working on your game for a couple of months or years and you don't want to switch to another render pipeline, you can still work on the built-in render pipeline, which is the old render pipeline, the fixed render pipeline that we are now calling the built-in render pipeline. There are some advantages of the built-in. The first advantage I will say is the fact that if you go to the internet, most of the documentation is written for the built-in render pipeline. Most of the things on the asset store today work with the built-in render pipeline. As we progress, more and more asset store developers are supporting HDRP and universal render pipeline, but yeah, there are some cases where you probably want to stick with the built-in render pipeline. Okay, so back on some theory behind the scriptable render pipelines or render pipelines and how they work. And again, these topics are not were not invented by Unity. These topics apply to basically any engine or rendering framework. So even if you, at the end of this presentation, you remember these things, I think it's very valuable for you as professionals to know, like, okay, this is how rendering in games work. This is not necessarily like a super in-depth presentation on that, but might get you an idea of how things work. So a render pipeline, basically the abstraction takes us to consider 3 steps. A render pipeline is in charge of 3 things. One is cooling, the other one is rendering, and the third one is doing the post-processing. So what does calling means? Basically, calling means to get a list or to get some sort of structure or data structure of all the objects in our scene that exist in our scene that might be rendered. Okay, I say might be rendered because even if we tell like, okay, this is the list of objects that we want to render, some of them might end up not being rendered, and we will see how in a second. So the most like a basic way of doing calling is using the camera viewing volume. Basically, you know, when you create your Unity camera, you have this pyramid-like shape, 3D shape. And basically what that tells us is everything that is inside of that volume will be rendered. Everything that is outside of that volume will be ignored, or at least that frame to be rendered. So in this case, you can see that we have like parts of our scene marked as to be rendered. And this is the first step. You can, of course, and especially with the scriptable render pipelines, you could determine, I don't know how to pronounce that word. You could change the way the cooling works, right? If you have some specific use cases, you could add some other conditions on how the cooling works, but this is the basic one. Now, the next step is to do the rendering. After we have all those potential objects to be rendered, we need to actually color those objects, right? We need to compute which pixel will have shadows, which pixel will have like light, if there's some light bouncing around, if those light bounces should affect my objects, the material, the properties of the material, the textures of the materials, etc. So that's the next step. Now you can see here in this image in particular that even when some of these objects were marked as to be rendered, there are some objects that won't be rendered because they are behind some other objects. So this is where why I was telling you before, like these are probably going to be rendered, but might not end up being rendered. And now we have to think not about objects as Unity objects. We need to start to think about what is called what we call fragments. And if you go to books or articles on the internet or tutorials, in some places they call fragments pixels, and the other way, you can think of fragments as pixels. However, the difference, and it's just for you to know, a pixel is something that you see on screen. A fragment, like on your iPad or on your mobile device or on your monitor, a fragment is not necessarily a pixel, right? But I understand that it could be the same thing in some cases, but in this case, think of each individual, the smallest thing that you can see in your scene, or that your shaders can see, are called fragments. And probably you have heard about this concept of fragment shaders. That's where these concept come from. So yeah, the next step is to do the rendering. We have to decide if objects are going to be opaque, transparent, the order of the objects, etc. And the last step, and let me see how we're doing on time. We have time, is doing the post-processing. So basically, before sending the image that we already rendered, we can apply some effects to the image, to that like buffer that we have or that texture that we have, and apply things such as bloom or some reflection into the space, etc. So these are the 3 steps that our Scriptable Render Pipeline basically executes, and that you can modify if you want. So talking about the Universal Render Pipeline, again, it's a Unity authored render pipeline. That means that we are constantly upgrading it. We're constantly optimizing it. So if you choose a Universal Render Pipeline, you can rest assured that Unity will be providing like all the support, because this is like, and the name, universal name, comes from that, right? Like we want to fully support it everywhere where Unity runs. It's developed with beautiful graphics in mind, so you can create gorgeous looking games, but also it's been developed with performance in mind. So you remember that I mentioned the high definition render pipeline. That render pipeline comes with other like advanced features such as real-time ray tracing and things like that. The Universal doesn't have those features, but if you want your game to be executed on a Switch, on an Android device, on an iOS device, on the Xbox One, PlayStation 4, a WebGL browser, etc., the Universal Render Pipeline will run on those on all those platforms, while the high definition won't run on many of those platforms. It's getting better, the support, but yeah, right now that's one of the differences. It's also extensive. You can take the code, you can extend the code, and you can actually, without doing so much coding or not coding at all, and I'll show you how in a second, you could potentially extend the way the Unity is rendering your game. The core systems are updated automatically, so you don't have to worry about making sure that if something changes on the core rendering side of Unity, you have to support those changes. We are managing that for you, and that's the same for the high definition render pipeline. They supported in 2019.4 LTS and up, and actually even earlier than that. But yeah, the recommendation, and also for those of you who are new to this new long-term support tech stream, basically the 2019.4 or 2019 LTS is the latest release on the 2019 lifecycle, is the most robust release. is a release that we will be maintaining and supporting for 2 more years after it was released. And this was released, I think, like a couple of weeks or months ago, I don't remember. But yeah, if you are working on something and you don't need to be changing or testing the newest features, the best approach is to stick to the long-term support version. And once, let's say in a year from now, when the 2020 LTS version is out, you can jump from 2019 LTS to 2020 LTS, and you don't have to go through all the versions in between them. Okay, platforms that are supported by Universal Render Pipeline. Basically every platform that Unity supports. And then let's start and let's jump into Unity. I hope that was kind of interesting. Let me know in the chat if that was interesting, or if it was not, also let me know. But yeah, I think it's sometimes it's important to understand the internals of how these things work, because most cases, if you go to the Unity webpage, you will see like tutorials on how to implement things, but sometimes we forget to mention why or how they work under the hood. So awesome, thank you, Billy and Harsh, thank you. So this is the boat attack demo. This demo has been around for a couple of years. It's developed by part of the team that works on the Universal Render Pipeline. It's on GitHub, it's free, you can use it, you can grab the code, you can grab the assets and use them as starting points for your game. I wouldn't say it's like a project for people who are starting with Unity. It's kind of super complex, but has some features and have some things that at first might look a bit like weird, right? So it's not a project for starters, but you can download it, and if you like to play around with stuff, definitely I recommend it to you. So it's a vertical slice of a game, and also an interesting thing. When we talk about vertical slices in games, we basically mean it's a piece of the game that is totally that works, right? It's just, let's say, one level in a game that might have 20 levels, but the one level has all the features, all the, you know, everything. So unlike a prototype, where a prototype might have some things that will change later and some code that might not be used in the end, a vertical slice is just a piece of a game that has to be completed, while a prototype is just like a tech demo, if you will. So it comes with some levels, it comes with some viewing modes. You can play it against the AI, which the AI is not super intelligent, but if someone is interested in artificial intelligence in Unity, you could take this project and generate better AI for this game. Okay, so it's a boat game, it's a racing game. You can see here that I'm not playing. It comes with an spectator mode. So basically the boats just go around in a circuit. And it's gorgeous. This project is beautiful. It runs on a Switch, it runs on a PS4, it runs on an Xbox One, it runs on an old-ish Android device. And I think it was an iPhone 7 or something like that. I don't remember, but it was not the latest iPhone, and it was working at 30 frames per second. It looks amazing. And changing from one platform to the other, it's super straightforward, similar to how it usually is in Unity, switching from one platform to the other. You don't have to configure things on the rendering itself, but you can, and I'll show you how. You can activate or deactivate features depending on basically the hardware that you are running the game on. So this is boat attack. Let me open another scene and let's explore it for a bit. There are a couple of presentations on the Unity YouTube where they talk about boat attack in general, like the code and many things. Here, I'm just going to be focusing on a couple of features related to the Universal render pipeline. Let me just
Arturo, and before you do that, we have a question. It's actually been sent anonymously. And the question is, do URP and lightweight render pipelines have same features?
That's an amazing question. Thank you, Anonymous Hero. And the answer is the universal render pipeline and the lightweight render pipeline are the same thing. A bit of history. So when we started working on these rendering pipelines, we named the rendering pipeline lightweight render pipeline. However, many users and even internal Unity people thought that lightweight meant like, okay, if I want my game to look bad but run on all the devices, then I will use lightweight. And in reality, that the name didn't reflect the actual purpose of this render pipeline. That's when we decided to change the name to universal. Now, they are the same thing. The lightweight is deprecated, that doesn't exist anymore. So it became universal render pipeline. Regarding features, I have to say that from the top of my head, I think all the features in lightweight are now in universal, but not all the features in universal are in lightweight. And in this case, they will never be because lightweight is dead. So yeah, I hope that answers the question.
Thank you, Arturo.
Yeah, thank you. Okay, so this is Borotech again. There are a couple of very interesting things taking place here, but let's take a look at some of them in the scene window. So the first thing that comes to everyone's attention when we see this demo, and sorry if I'm not looking at you, but the monitor I'm looking at is on the other side, is the water. The water here is not necessarily something that comes with the universal render pipeline. However, the universal render pipeline allows you to have water, beautiful water, such as this one. But this water effect also uses some C# code, etc. The good news is that you can get the water solution and use it in your games. In the past, before a couple of new features of universal render pipeline were added, you would need to basically have the same water or the same visuals. Now you can change the visuals without having to change the water behavior. So there's this game object called water over here, and you can see that it's a C# script. So the actual water effect comes from two places: the C# part, which generates the mesh, and the rendering part, which basically generates how this looks, right? There are many things that you can play around with. You can change like the wave count. So for instance, you can add more waves. I can change the height of the waves. So, well, this is ridiculous, but you get the idea. You can change the wavelength. You can actually change the direction of the wind. So let's say I'm looking into the horizon there. You see that the water right now is moving towards the left side of your screen. I could tell to change the script to align with the scene camera. So now the wind is moving in the direction of my camera. So this is for the water. Another interesting thing that universal render pipeline allows us to have is different types of reflections. Let me see where we can see better reflections. Like here, you can see in the water that we are reflecting the sky. We are reflecting some of these mountains, etc. This is achieved using a planar reflection solution, and this is again part of the water rendering side. Built into universal render pipeline, we have the cube maps reflections, we have reflection probes, and they will work. But remember that these solutions, they need you to create reflection probes throughout your level. If you don't have them, then you won't see the effects. Planar reflection works basically based on the image that you have, so you don't need to position all those things all over the place. Here we have post-processing taking place. Universal Render Pipeline comes with a post-processing stack version 3. Unlike how it was in the past, how it was with the built-in render pipeline, where you had to go to the package manager or to the asset store to get the post-processing. Now post-processing comes built into the rendering pipeline, so you don't have to install a different package, etc. Let me also show you that we have some other things here. Okay, the next thing, sorry, I'm looking at my notes. Just a quick overview on how to get the universal render pipeline in a blank project. It's super simple. I already have it here on this project, but you just need to go to the package manager. You need to search for the universal render pipeline package, universal RP. You can see that it comes with two dependencies, core RP library. You don't have to worry about that, and shader graph. That's one cool thing that universal render pipeline brings, which is a shader graph. We will see how a shader graph works. But yeah, you just install the universal render pipeline or update it. That's the first step. The second step that you have to do is to create an asset, a configuration asset for that rendering pipeline. And you can achieve that by right-clicking anywhere in your project folder, create, and then rendering universal render pipeline, and you need to tell that you want a pipeline, this forward renderer. You create that one, and you can see, well, it's already here, this one that I just created. Here you will configure the features that you need in your render pipeline. So for instance, if you need a depth texture, if you need an opaque texture for certain like effects or certain things on your shaders, you activate them. If you don't need them, you can just deactivate them. If you don't need high dynamic range, the space, you don't need to have it. If you don't need anti-aliasing, if you want to modify the render scales, how you want your shadows and lights to work, etc. You will need to play around with these values, but this is something that you will just do once, and that's it. Okay, then after you have this asset, and remember, don't worry about memorizing this. I understand that I have so many assets already here and it's confusing. Just remember like the steps. We download the package from the package manager. We create a configuration asset, and then we have to assign that configuration asset. So for that, I go to Edit, Project Settings, and then on Graphics, I have here a new option that asks me for a Scriptable Render Pipeline settings. I have to drag and drop my newly created asset here, and that's pretty much it. Now, just to avoid some confusion in the future, because this was driving me so crazy when I started working on this, and I had no idea why things were working when they were not supposed to be working. Under quality, you can see here that I have another rendering property, and I have the same pipeline asset assigned. And this means that I could have multiple configuration assets for different rendering needs, right? So if my game is running on a 5-year-old Android device, probably I don't want to use all the high-end features. So maybe I will create another asset with less features. Will not look as good, but it will run super fast, right? So in this case, you can see here that I have the, and I hope that the zoom is good enough. I have this pipeline asset high, which comes with all the features basically turned on. But if I go to medium, you can see that I assigned the medium configuration file, and the same for low. So you can have multiple files, multiple configurations here. I'm gonna leave it with the high one, and we have 20 minutes, so I have to run a bit. So yeah, I activated this. That's pretty much it. If you don't need to do anything else, you basically, you're done. Like you have universal render pipeline in your project. We have some built-in shaders or built-in materials that you can use that are PVR based, on-lit, or sprite based. So that could be it, right? But the fact that we're using this render pipeline is because we want to achieve more with the rendering. So next thing that I want to show you is shader graph. So shader graph is a tool that allows you to create materials or that are animated or not using just nodes. And you might be wondering, why do I want that? Let's take a look at one example. So you can see here that we have this rock here. And if we take a look at the bottom part of this rock, we see that it has some sort of like a wetness, right? And it makes sense because if this rock was real and it had some direct contact with the sea or with water, it will absorb some of that wetness or humidity, okay? So it makes sense. But let's say at some point, one of our level designers tells us, oh, you know what? I want this not to be too high. I want this to look that it's inside the water a bit more. So if this was made in a texture, then the texture, the person working on the textures will need to basically paint the texture of the wetness to somewhere that matches the change in height. However, if you can take a look here, I'm gonna move my rock under the water. You can see how the wetness updates depending on the position of my rock. And this is great. And this is incredible because now I can have multiple versions of these rocks at multiple heights, and they will look organic. They will look realistic. So this is achieved with shader graph. Another use of shader graph, and in the similar idea, oh, now these things are flying in the sky, just ignore them, is the fact that you can see that in some parts of our rock, we have some sort of grass. So what if I said, like, you know, I want to rotate rock around, and I hope you can see that the grass adapts to the rotation. See how it appears? Basically saying, okay, if I'm facing up where the sun it's basically directly affecting me, then I will let the grass grow. And I can basically have multiple variants of these rock to make a large level just by having one version of my model, because that's another important thing to mention, right? Like if I want this game to run on a mobile device or even on a console, you probably, if you can use just 3 mountains or 3 rocks and just scale them around, that's great, because you will just be paying the price for three meshes in memory and 3 versions of the textures. Now, let's see how the shaders work. And I'm not going to go too deep into shaders, but if at some point you want, oh, I hope Unity didn't crash. No.
Arturo, while you're
Yes.
getting into shaders, we actually have a question. Speaking of, very realistic visuals, we have a question. Are there any plans to add ray tracing to Universal Render Pipeline? And if so, how will that affect performance?
Yeah, so the answer is there are no plans on adding ray tracing to the Universal Render Pipeline. If you need that, you probably have to use the high definition render pipeline. And the answer is, and these things might change, and we're recording this, so if in the future we actually provide ray tracing here, don't quote me on that. But the thing is, we want this to be supported in many platforms, right? If we bring ray tracing, that means systems without ray tracing won't be able to basically execute, right? So universal is basically if you want to reach out to all these devices. So ray tracing would limit that. However, there's nothing that I can think of will prevent something such as ray tracing from happening in Universal Render Pipeline, but that's not something that we have on the radar or on the pipeline.
Great. And there is one more question, and it is there any difference between the post-processing effects in the fixed render pipeline, which I'm assuming is the built-in render pipeline, and the universal render pipeline?
Yes, there are many differences. For once, all the effects that are on the built-in render pipeline are not yet on the universal render pipeline. So yeah, that's another interesting thing to consider when you are deciding which render pipeline to use, at least today or in the next months, that if you need a specific effect, it might not be available yet on the Universal Render Pipeline post-processing stack. So yeah, not all the effects are on the Universal. However, the effects that we have on Universal Render Pipeline are faster, and in sometimes it's just like 5 times faster, but in sometimes we have like crazy numbers of how faster it is than the ones in the built-in render pipeline. But yeah, and the goal is to have like parity between them, but today we don't have that. So yeah, but the team is working on that.
Thanks, Arturo.
Thank you. So this is a shader graph. As I was telling you, if you want to create an effect, a visual effect that can be, again, animated or not, you can do it just using nodes, a node-based system. So you don't have to code. How this works is you have a master node, which basically think of it as the material that receives all the inputs. And those inputs basically are like the albedo or the base color, the normal map, the emission map, the metallicness, the smoothness, the occlusion, the alpha value, etc. And then you will feed those values just by basically doing all sorts of transformations to the data, right? So I can, for instance, have this rock smoothness value. So I drag and drop it here. And then I want to do some multiplication, or I want to do whatever, and then I can simply feed that into the next node, and so on and so forth until I feed that into the PBR master. I was going to say that if at some point you want us to also talk about the shader graph, it will be great in the future. So yeah, that's it for like shader graph and the basics of the Universal Render Pipeline. Let me go back to the presentation because now we're running low on time. We don't have to hard stop in the next hour, right, Elena?
No, Arturo, if you have time after this, then you can carry on because the webinar has been set up so that you can end it whenever it's done.
Yeah, I have time. So
okay,
yeah, no, we're recording the call. So
yes.
I apologize for taking more time, but yeah, I'm sorry, but yeah, you can get the recording later. Okay, so now we already understood like how to install the Universal Render Pipeline, how to use shader graph. You can do other things with how to use the post-processing stack, etc. But now we're going to talk about some features that are new to the Universal Render Pipeline, but are like, I think are a key part of why you want to use the Universal Render Pipeline, right? And it's the fact that you can have custom renderers. And we're going to talk about that in a second, okay? So the Universal Render Pipeline, as we were saying, has this modular design. It has renderers, and it has some passes and features. You can also listen to or register to camera callbacks to get information from the camera. So for instance, if the camera is about to render something, you can be listening to that event and do something before the camera renders. If the camera is rendering, then you can do that once the camera is rendering. If the camera already rendered something, you can do something after the camera rendered. So you have control over those steps, and you can basically inject to those events. So this is the rendering loop, how it looks. Remember, we have this pipeline that is a pipe, but this pipe doesn't execute just once. It's executing multiple times per second. So we have the rendering loop executing all the time. And basically, we have one event, which is the begin frame rendering, and the other event, the end frame rendering. You could do things here, right? Each camera has its own rendering loop. So if you have more than one cameras, then you have to be conscious because this rendering loop is executing more than once. So in most cases, you just want to have one active camera at a time, or one camera rendering. Even if they are not visible on screen, at least the calling part of the camera is being executed. So yeah, it's not something that you want to have. Okay. So in the camera loop, again, we have the begin frame rendering and the end camera rendering, and then we have these steps where you can set up the calling parameters, and we do the calling here. then we do we build the rendering data, and then we execute the rendering. Here, what we can do is inject those render passes with some additional features. Now, don't worry if this is too complicated, because it is. I still, to be honest, don't quite, I don't know this by memory, right? If I don't have this line, I won't remember like the steps or anything, but I just want you to understand the idea behind how this works, right? And the fact that you have like multiple steps in the rendering process. Okay, so let's see this in an example here. We're going to be using the same scene, and you can see that this is how my scene looks by default, right? So the only thing that we have here is the water, which is using a render feature, because we do something that we will take a look at right now. So I go here to data, then universal render pipeline. And remember, we had these previously created pipeline assets. I have this high pipeline asset over here. And you see that I have these different renderers. I have one normal renderer. If I click on this renderer, I have this normal renderer that comes with one feature. And this render feature is the water render feature. And this render feature, and again, don't worry if these are like renderers and render features and render passes. It's a lot of stuff, and the goal is not to memorize those things. It doesn't really matter. Just that this can be achieved. Okay. So in this case, in the normal one, we have just one render feature that we are basically executing to render these caustics in the water. Basically, the caustics are these effects that happen in the not in the surface of the water, but in the basically on the opaque objects that are under the water. And it's because the light gets into the water, but because the water is moving around, some of these light rays just bounce off and don't get there, and some of them get like distorted. So this is the effect that you get. You can get a debugging view, and you can see that we have the caustics being executed just where we have the water. And if I go back to change the caustics and the water values, these will be reflected as well. So this is a water render feature that we are basically using on top of our render. So I'm going to disable this. I'm going to go back to the pipeline asset high. And then the next thing that I want to do is I want to use another custom renderer. I could create a new one, right? But I don't want to create a new one. I already have them here, but you could create your custom renderers. And I'm going to select the second one, and I'm going to activate that as a default. In this case, you probably notice that I don't have my caustics anymore, and let's see why. I'm going to click on that retro renderer. Is this one over here? And you can see here that I have more than one feature, okay? But these are turned off right now. So I could create, the way you can create more features, in the past I only had this water feature. Then you can see that we have the caustics back. You can create a new render feature by add a render feature and configure one. I already have other render features over here. So let's start activating some of these render features. Let's see what's going on. So the first one that I want to activate is this outline pass. So I activate it. You can see that now we have an outline effect in our objects, right? So you can see that some of these objects have the outline effect. If I get too close to some of them, I can see those effects. You can see that it's thicker in some parts, etc. Now you can see here on the settings that I have events, right? And I'm telling here to apply this effect after I render all the transparent objects. So if I have things near to the water, let's see if I have something here that will be visible or under the water. like here, you can see this outline. I hope you can see it. This is being rendered because we are rendering this after rendering the transparency. But what if we say, I want to render this after the opaques? Then the transparent event happens after the opaque event. Opaque objects are objects that are not transparent, basically. So here's the idea of injecting or subscribing to different events in our rendering from the previous slide that I was showing you, right? So you can play around with these events. And what's going on here is basically we're applying one material. This material in this case is called the Matte Pass Outline Sobel. It's just a material that has some features. You could edit the shader. It's just a shader under the hood. It can be a shader graph or any regular shader. Let me go back to the retro effect. So that's the outline feature. Then let's activate the Toon Pass. Now you can see here, it doesn't look that toony. I didn't make this effect. I wouldn't say this looks toony. But what's happening here is that we are basically, oh, and this is flying this guy. We're basically using one texture, and let's open the material over here. This is after rendering the transparency, but again, this could happen even before rendering. Let's see what happens if I say before rendering opaques. Yeah, okay, so we're applying this effect before the opaques are being rendered. So basically everything that is opaque here won't have that effect. So we want this after rendering the opaques, I guess. You can see that the sky is not being affected. If I want to affect the sky, here's a question. Which event should I subscribe to? Maybe after rendering the sky, right? So now the sky has this color switching basically, and you can see that the material basically uses a texture to just do the switching here. There's another value, the posterize amount, that I can play around with to make sure that I have a less obvious or more obvious effect. Okay, now let's go back and activate one last effect here on our retro effect, and this one is called a retro pass, which basically will pixelate everything here. So I activate it, and you can see here that now we have a game, kind of like a PlayStation 1 type of game, although yeah, in PlayStation, they didn't have these resolutions or many of these like real-time shadows, they didn't exist there, but you get the idea, right? And the only thing that we're doing here is just applying a shader. And I didn't have to code anything. Besides the shaders, you don't have to code anything here. You just need to tell, okay, use this material and execute that on all the objects that are on these, like this pass. Or when you, not necessarily, don't think of these as objects, just basically think of all the things, whatever they are, on a given step in the rendering. So yeah, that's it. There's another effect or custom renderer that we have, which is a gradient fog. So I'm going to activate that one, and you can see that it looks like a Silent Hill type of rendering. Oh, what happened? Okay, yeah. Which is great. Again, no code. This is how it works. Okay, so let's go back to the presentation. Oh, well, just 1 minute. So yeah, so these are basically what we just talked about. These are these render feature that allow you to have like modular rendering that you can use to extend the behavior of the universal render pipeline. You can inject these custom effects. You can use data from the camera, which is what we were talking about. You can view them in the frame debugger. I didn't show that, but yeah, there's the frame debugger, and you can debug these effects in the frame debugger. And next thing is the 2D renderer. The 2D renderer is basically a custom renderer, similar to what we've been doing, having these custom renderers, but optimized for 2D. So I have this other example, and I'm gonna go faster now. This example also available on the asset store for free. You can grab it, you can play around with it. It's using the universal render pipeline, but using the 2D renderer. Why do we use the 2D renderer in this case? Well, for one main reason, and the main reason is having the 2D lights. You remember, if you've used Unity, if you want to have lighting, you need to use 3D lights. And 3D lights for a 2D game is an overkill. And in some cases, like if you're using sprites, they cannot talk to each other. They live like in separate worlds. So in this case, you can see how my character is affected, and even the background, by 2D lights. It allows us to have like other features, you know, like shader graph in 2D, etc. But I'm gonna show you real quick how the 2D lights work. So once you have your project configured, you can create, or you have to create, again, go to create, rendering, universal render pipeline, and you have to create a 2D renderer asset. Again, just to configure how the rendering will work. After you have that, you will have these new options under light. You have light, 2D, and then you have different types of lights. So in this case, I want to show you these freeform lights. That it's not the one that I want, the other one here.
Arturo,
Yes.
I'm sorry to interrupt. I just wanted to say that I'm going to actually hop off to carry on, but I wanted to thank everyone for joining, and please continue to enjoy Arturo's presentation. We will communicate the recording of this presentation to Isaac and Kelechi. So if you guys came in a bit later or would like to review some of these features that Arturo showed off in more detail, we will send the recording shortly. So thank you so much again, and continue to enjoy the presentation.
Thank you, Elena.
Thank you. Bye, Arturo.
Bye. Okay, so this is a 2D light. This can interact with sprites, and the great thing about this is that you have you can now have games, 2D games that are in daytime or nighttime, and you don't have to create basically two variations of the textures. You can just have one, and then use the lights to make sure that the things are properly lit. Okay, you can have again like a point light, a global light, if you want to have something similar to the directional light in 3D. That's it for the 2D lights. You have also a shader graph in 2D. So let me open my shader graph here. This shader graph is for the trees. If you want to have the trees with some sort of animation simulating the wind. It's the same pipeline, it's the same way of working. You just create nodes, and these are actually documented. So if you download the project, you will have nodes and some documentation on that. You just need to feed the values into the master node. So that's pretty much it. And before saying goodbye, I want to show you a feature that was recently added to the universal render pipeline, which in reality is a feature that existed in the built-in render pipeline for long. We didn't have it in the universal, which is camera stacking. In multiple use cases, you want to have more than one camera rendering your game. So for instance, if you're working on a multiplayer game, a local multiplayer game, you want to render one camera to the left side, another camera to the right side. That's one use case. The other use case might be when you want to have some sort of things, such as this image over there. You can see that that camera or that billboard over there is rendering some UI, is rendering one character, and is rendering the stage. How is that working? Basically, is stacking cameras. We have one camera for the UI, one camera in the stage, and another camera basically and the two cameras just being stacked and generating the final image. And then you send that image to a render texture, and then the render texture to render that there. There are other interesting examples. I'm not going to explain all of them, but they are available, and I will give you the links. They're available on GitHub, and you can have so much fun with them. For instance, this one. And recently, my colleagues, they released a demo on how to use these demos in particular. So this is so beautiful, and you can grab it if you're working on a similar game. You can basically use it as a starting point for your game. And that's it for the new features. Things that are coming, screen space ambient occlusion. At deferred mode, we only support forward mode, clear code also. We don't have that right now. We're improving the reflection probes, and we're also adding some extra features for the shadow. Here are some references. I can send you the presentation. I can send you the link. And I want to thank you all for being here. I hope that you learned something. I hope that you had fun. And if you have questions, now is the time to ask them. So thank you. Thank you very much.